The history starts on July 14th, when Chandrayaan-3 mission was successfully lifted off from the Satish Dhawan Space Center in Andhra Pradesh's Sriharikota by the Indian Space Research Organization, ISRO. On July 15, 2023, the orbit-raising maneuver of Chandrayaan-3 spacecraft started. The orbit-raising maneuver of Chandrayaan-3 spacecraft was carried out in 5 stages. And on August 1st, a key maneuver to slingshot the spacecraft towards the Moon from Earth's orbit was carried out. Let us understand what orbit-raising maneuvers and slingshots means. When a spacecraft is launched into space to explore any heavenly bodies, initially, it is made to orbit Earth rather than heading directly towards its destination. Instead, it is made to orbit Earth in an oval orbit, meaning the aircraft sometimes comes too near to the Earth, and other time it goes too farther. This maneuver is carried out to save fuel and time by using the gravity of the planet to provide extra speed to the spacecraft. Finally, when the required speed is gained and when time is right, the direction of the spacecraft is changed towards its destination by giving it a push. This process of firing a spacecraft towards its destination using the gravity of the planet is called slingshot. On August 5th, Chandrayaan-3 was successfully inserted into the lunar orbit. Now, again the same maneuver, but this time the opposite one, the orbit-lowering maneuvers, were performed around the Moon. The spacecraft kept on orbiting the Moon in an oval shape to decrease its speed and altitude gradually. On August 17th, lander module of Chandrayaan-3 spacecraft was successfully separated from the propulsion module. After 41 days and the 15 minutes of terror, at 6:04 p.m. on August 23rd, Chandrayaan-3 created history. The lander module landed successfully on the lunar surface, making India the first country to land on the lunar South Pole, a land of mysteries that are waiting to be deciphered. The lander module consists of Vikram lander and Pragyan rover. Let's have a quick look at what these two are and what are they capable of doing. The Vikram lander comes with multiple sensors to ensure a safe touchdown while landing. It also consists of side-mounted solar panels, which can generate 738 watts of power that will be used to explore the lunar South Pole. The Vikram lander has 3 payloads. One is Ramba LP, stands for Radio Anatomy of Moonbound, Hypersensitive Ionosphere and Atmosphere, Langmuir probe. It features a 5 cm metallic spherical probe mounted on a 1 meter boom attached to the lander's upper deck. Ramba LP is used in in situ measurement of the near-surface plasma density and its changes with time. In situ measurement refers to the measurement in which the instrument is located directly at the point of interest and in contact with the subject of interest. And plasma is superheated matter, so hot that the electrons are ripped away from the atoms, forming an ionized gas. Plasma is formed when the gas is heated to extreme temperature. Detection of plasma can discover the presence of volcanic activities on the Moon. The initial assessment of Ramba LP indicates that the plasma near the lunar surface is relatively sparse and very low. It is characterized by a number density ranging from approximately 5 to 30 million electrons per cubic meter. Second is CHASTE, meaning Chandra's Surface Thermophysical Experiment. CHASTE is used to carry out the measurements of thermal properties of lunar surface near polar region. CHASTE has a temperature probe equipped with a controlled penetration mechanism, capable of reaching a depth of 10 centimeters beneath the Moon's surface. The probe is fitted with 10 individual temperature sensors to provide a precise measurement of the temperature. The graph shows the first observation made by the CHASTE as revealed by ISRO. We can see that the surface temperature on South Pole during lunar day is around 50 degrees Celsius. And when the CHASTE drilled up to 8 centimeters below the surface, the temperature sensors recorded the temperature of -10 degrees Celsius. This discovery can be very helpful because the drastic decrease in temperature indicates how insulative lunar soil is, which gives another hope for the possibility of ice beneath the Moon's surface. And the third is ILSA, meaning Instrument for Lunar Seismic Activity, which will make continuous observations of the lunar seismic activities, as well as the meteors impacting the lunar surface. It can detect precisely any movement activities on the Moon's surface. This instrument works in similar manner to the seismograph used on Earth, but instead of plotting the data on a paper, CHASTE measure it digitally, making the data more precise in seismic measurement. On August 26, 2023, ILSA measure the two seismic activities, as revealed by ISRO. In the graph, we can see the data in yellow was due to the movement of Pragyan rover, and short after, ILSA recorded another vibration, which we can see in graph in blue color, which was a natural moonquake, according to ISRO. Let's take a look at the Pragyan rover and what it has discovered so far. The six-wheeled Pragyan rover is designed to provide elemental composition data of the lunar surface and its atmosphere. It weighs 26 kilograms and has two payloads. One is the APXS payload, stands for Alpha Particle X-ray Spectrometer. This is used to derive the chemical composition and infer mineralogical composition of lunar surface. The other payload, called LIBS, which stands for Laser-Induced Breakdown Spectroscope. It is also used to determine the elemental composition of lunar soil and rocks around the lunar landing site. APXS and LIBS both have the potential of determining the presence of magnesium, aluminium, silicon, potassium, calcium, titanium, and iron, but they have difference in their working. APXS works on the principle of alpha particle and radioactive decay. APXS has a curium-244 radioactive source with a half-life of 18 years. It continuously emits X-ray and alpha particles. X-rays are a form of electromagnetic radiation, similar to visible light, but have higher energy and can pass through most objects. Alpha particles are basically helium atom, which is heavier. When the alpha particles are fired to an atom, it may remove one or more electrons from the atom. Atoms at higher energy level falls to lower energy level to fill the vacant place. While the electrons falls to lower energy level, it releases X-ray called secondary X-ray. Every energy level has a unique energy for different elements. By analyzing the energy emitted by the secondary X-ray, we can exactly pinpoint which element is that. Whereas, LIBS works on the principle of laser. LIBS induces high laser beam towards the moon's soil. The beam, which produces intense heat, is hot enough to convert the soil into plasma. These plasma emits light waves of different wavelength. Now, for every element, there is a unique wavelength for light produced by it. By measuring the wavelength of these lights, we can say exactly what elements are present in the soil. Both APXS and LIBS have confirmed the presence of aluminum, sulfur, calcium, iron, chromium, and titanium on the lunar surface. Further measurements have revealed the presence of manganese, silicon, and oxygen, according to ISRO. Among these, the most interesting is the sulfur and the oxygen. Sulfur usually originates from volcanic activities, and its presence on the moon can offer better insight about the moon's formation, its composition, and its history. You would think, how the presence of oxygen is possible on the moon? Well, the oxygen is not available in free state on the moon, but it is found in minerals in compound form, bonded with other elements, like silicate minerals, carbonate minerals, oxide minerals, etc. This finding can be a boon for the space exploration, because if we are able to extract oxygen from those minerals present in the moon's rock, it can be used as a rocket fuel, survival of the living beings, and many more. One day on the moon is equal to 14 Earth's day. So, after 14 days of exploration, the landers and rovers system has been switched off due to the absence of sunlight. We hope the landers and rovers system will soon resume as soon as the dark side faces the sunlight.